To start the base 10 place value unit, I start the day by pulling up this place value chart along with my concrete manipulatives, the base 10 blocks that the kids can actually touch and hold and actually act out the trading process. What I would do is have kids come up to the board and act out the trading process for as we move from one place to the next one higher. So to start in the ones place, my students would discuss how the ones place relates to the place one larger than it, which they know already to be the tens place. We discuss how, in order to get from the ones to the tens place, we group by 10. So instead of having 3, 4, 5, 6, it's a little slow, 7, 8, let it catch up. 1, 2, 3, 4, 5, 6, 7, 8, 9. At the ninth one, if you were to add another unit on, this is no longer efficient packaging. There's another size package that we can use that would be more efficient than this. So then we bring in the rod. And through this, the kids see that the tens place is, and I would have them write this in on a similar note page that they would have. The tens place is 10 times larger than the ones place because the tens place is 10 groups of 1. Okay. So we continue to discuss how we move forward. How do we get from the tens place to the hundreds place? Well, we continue to package by 10. But at this point, we're packaging rods as opposed to units. So once we get to the 10th rod, we would exchange that for a flat. You can see there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rods within this flat. So students should see, sorry, I'm kind of moving more quickly because I don't want to waste time by dragging out all 10. This is for teachers, so I'm assuming they get the point. To go from the tens place to the hundreds place, then what we did was we multiplied by 10. Okay, so the hundreds place is 10 times larger than the tens place because the hundred place is actually 10 groups of 10. Here's just one 10, and there's 10 groups of it as you move forward. Okay, so it's 10 times the size of the rod, or 10 times the size of 10. So students are starting to see at this point a pattern develop. Using the actual concrete manipulatives, please show, it makes it that much more memorable to actually show the 10 times, the 10 trading out. So what I would do is I would pull out 10 flats and group them all to form the 1,000 block. So in the actual grouping process, students will again see that this pattern persists and that the thousands place is 10 times the size of the hundreds place because the 1,000 is 10 groups of 100. If you think of this bottom layer as being the 100, the flat, and then there's 10 flats stacked on top of each other, that 1,000 block is 10 times the size of a 100 block. Now to move forward, the students are definitely seeing a pattern. We know that this next place, the 10,000s place, should be 10 times the size of the thousands place, meaning it should be 10 groups of 1,000. So what I do is, even though it can be a tad bit time consuming, I take one of the thousands cubes and right before the student's eyes actually use it's a feature on the Promethean called Duplicate that really quickly copy and pastes an image. So what I do is talking this out with them, I ask them how many times I should duplicate, and we form the answer that we should have 10 of these thousands because there's 10 groups of 1,000. So at this point we're at 5. And then here we are at 10. So actually this should form a rod. Let me move this over here so I can, this should form a much larger rod. So I'm going to actually make it smaller so that it can fit within this area right here. But it is 10 thousands, and actually is a rod, kind of following the same pattern that we've been starting to work with. A cube, a rod, a flat. A cube, a rod, and we would expect next to have a flat. Let me make this a tiny bit bigger so we can visualize. It's 10 thousandths. Now the kids are starting to, get a picture of the magnitude of these large numbers. Because you're holding up 1,000 block concretely, those base 10,000 blocks, and you're telling them that there's 10 of these. And it really helps to hold one of the ones cubes up next to it to give them the relative size. There are 10,000 of those tiny ones cubes within that giant rod. So moving forward, the students can tell you that the pattern has become so clear that the 100,000ths place is 10 times larger than the 10,000ths place, and that you should expect to have 10 groups of 10,000. So what you would do is, and I'd like to do this again in front of them again, and you would form a flat in doing this, which again is following the pattern. Here's your one group of 10,000. You need 10 of these. So here's my second group of 10,000. Here is my third group of 10,000. My fourth group, I'm going to move this. Fourth group of 10,000. Fifth group of 10,000. So at this point we're at 50,000. I'm just going to duplicate this entire thing. And here are 10 groups of 10,000. It doesn't look like the actual flat, meaning a square, but if you were to count it out, it's kind of squashed. You can see it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it is actually a square. The image just got a little squashed. So the students are seeing, the size of 100,000. And then to picture the following step up, the millions place. Now these place changes are becoming huge because we are now dealing with 10 groups of 100,000. And so now the students should see we're going from a cube to a rod to a flat, a cube to a rod to a flat. The next thing that we would expect would be a cube. So perhaps we take this and stack it on each other, 10 times. So this is a great discussion the initial day because students are really getting a picture of the magnitude of these numbers. And also it segues really wonderfully into the definition of base 10. So in the algebra unit, students are already pretty comfortable with exponents and how they're comfortable with the expanded form of exponents. They're comfortable using a calculator to find more challenging exponent solutions. Let me just write this back in here. I then segue into a discussion of let's just cross this out. These are the place values. I then discuss that each place value is a power of 10. So there's a really great way that I show this. What I do is I kind of get a blank screen. Let's see, and I kind of cover, let's see, where did it go? So I use this screen. Let's make sure that it is covering up everything. So we're going to reorder, bring to the front. And then what I'm able to do is talk about where the exponent numbers come from. So at this point, let's take a look at the tens place. Okay, and let's try to find out how we can represent the tens place using an exponent number. How many times are we multiplying 10 by itself? Just It's not even being multiplied by itself, so it's 10 to the first power. It's just this one lone 10 right here, times 10. Then what we do is we move over and discuss that in reference to the hundreds place. So how many times are we multiplying 10 by itself? Well, now we have 10 times 10 in order to get to the hundreds place. So the students would then, I would have them write out 10 times 10, and then the shorter exponent notation, 10 to the second power. Okay. And then we continue to move over to the thousands place, and students are seeing that to get from the hundreds to the thousands, we're simply multiplying by another 10. So now we have 10 times 10 times 10 to get to the thousands place. 10 times 10 times 10, and that would be 10 to the third power, multiplying 10 by itself 3 times. Moving over more to the 10,000s place. Oopsies. We can see that there's another multiplication by 10. So this would be 10 times 10 times 10 times 10. So this would be 10 to the fourth power. So students are seeing that each time we grow, we're adding, the exponent is getting one larger because we're multiplying by 10 one more time. And the final one I'm going to discuss is the 100,000s place, which we're multiplying by another 10. So our exponent should go from 10 to the fourth to 10 to the fifth because we're multiplying by another 10. And that is 10 times 10 times 10 times 10 times 10. So students are seeing that each time we grow, we multiply by 10, which means that each time we grow from one place to the next, our power increases by 1 because we're multiplying by 10 that one more time. This is a great opportunity to review the terminology of exponents. So students should recall the two terms, base and an exponent or power. So when you look at this number, the base is 6 and the exponent or the power is 5. So what I do is I let the kids look. I, will even highlight the powers of 10, and I'll ask them, why is it then base 10? And a student will notice that each of the places, each power of 10 has a base of 10. And so that's where they start to understand that this name is derived from, exponent vocabulary. Each place value has a base of 10. And then this segues great into other base systems because, you're still having powers of something, not powers of 10. If it's a base 3 system, you're having powers of 3. If you're a base 5 system, you're having powers of 5. So this initial discussion really helps the kids understand where these exponent numbers come from when they're looking at a place value chart in their room, and the pictorial representations of each place value. And this is a great start to the unit.